Today we are going to focus on the examples of differentiation. So let's start with this one right here. Why is the derivative of sine of x equal to cosine of x? That is the question. Is there a reason behind this, or someone just made it up? Why is it that when we differentiate sine of x, we have to get cosine of x? Well, we are going to prove this here, and all we need is the definition of derivative that we learned in the last lecture. The slope of the smallest triangle possible. So let's bring that back here. Definition of derivative. F prime of x equal to slope of the triangle. So f of x plus h minus f of x divided by h. And this is delta y divided by delta x, the slope of the triangle. But this one is a big triangle, and that is not good enough. We want it to be smallest possible, and that's why we have limit right here in the definition. Limit when h goes to 0, when the base of the triangle goes to 0. So let's make a box around this definition. It's going to be crucial. Okay, now we are going to use this to prove why the derivative of sine of x equal to cosine of x. And we have to find out about each term inside this definition. So let's take a look at the first term right here. Function of x plus h. So we will look into this. And to do that, we have to think of the function that we have right here, and it's sine of x. So in this case, our function is sine of x. So let's write that down. Fx equal to sine of x. This means that if we have an input of x and it goes through this function f, what do we get? We are going to get the sine of the input. So we are going to get sine of x. But let's take a look here for this function right here. This is function of x plus h, which means that the input is going to be x plus h instead. So here we are going to have this situation, x plus h as the input. It's going to go into this same function, and what we get out of that is going to be sine of the input, which is sine of, okay, let's use green for that. This one is sine of x plus h. So we are going to put that inside the definition. So let's expand over here, down here, equal to. Okay, limit is still the same. Limit of h goes to 0. But now function of x plus h becomes sine of x plus h. What about I use blue down here? Blue is better. So let me change the color to blue. Equal to limit of h goes to 0. First term, sine of x plus h. Now let's take a look at the second term. Right here, this is function of x. This one is easy. Function of x in this case is sine of x. So let's use that. Plus sine of x. Now divide this by h. Nothing changes there. Okay, now at this point we are going to do something with the terms that we have. I see this sine of x plus h, and I think I see this pattern, sine of a plus b. Okay, let's take a look here. Sine of a plus b. I see this pattern. And I'm going to apply the trigonometry property that I learned long time ago, maybe in high school or in middle school. So let's take a look here. This property. Sine of a plus b equal to sine of a cosine of b plus cosine of a sine of b. So let's use that over here on the right hand side. So with this, we are going to have this same limit again. It's going to be a lot of writing on this slide. H goes to 0. Now sine of A plus B, we are going to get sine A cosine B. Sine A, which is sine X, cosine B, which is cosine H, plus cosine A, cosine X, and sine B, sine H. Alright, the last term is still the same, sine X. Divide this by this H. Now, the next thing I'm going to do is to group these two together. This one and this one, because I see a common term of sine of X. So I'm going to group them together in the next line. Equal to limit of H goes to 0 once again. Now first term, sine of X cosine H plus sine of X together, group them together, plus last term cosine of X sine of H. Divide this, same term, H. Now you can see these two have the common term of sine of X, so I'm going to group them together. Now next line, limit of H goes to 0. Sine of X grouped together goes to the front, sine of X, and inside the parenthesis I have cosine. Oh, I'm sorry, I made a mistake over here. Let's change this to minus sine, and over here too. Alright, minus, minus, and minus over here. Okay, now inside the parentheses we have cosine of H minus 1 plus cosine of X sine H. Okay, now everything has to be divided by H. And at this point I'm going to do this. I'm going to split this fraction into two parts. So I'm going to take this out, division. I'm going to apply this division to each of these terms. The first one right here. Front term divided by H, and back term divided by H. And I keep the operation addition right here the same, the sum. Now, what you see right here is a limit of the sum of two subfunctions. So let's take a look here. On the left-hand side, we have this property. Limit. If you have a limit of two subfunction fx plus gx, okay, let's have gx here. And let's assume that x goes to a. This is going to be equal to, we can distribute the limit to each subfunction. Limit goes to f and limit goes to g. And we keep the plus sign the same. So here we have limit of fx, x goes to a, and plus the same, limit of g of x when x goes to a. This is x goes to a. Now we are going to apply that to the definition that we are working on the right hand side. So limit over here at the front is going to go into the first subfunction and goes to second subfunction, and we keep the plus sign the same. So let's see what we get here. This is equal to limit of the first subfunction. H goes to 0. So we have sine of x cosine of h minus 1. Okay, I think I need space, so I'm going to move a little bit further at the front. So we have sine of x cosine of h minus 1. Divide this by h. Now the limit goes to the second subfunction. Plus sign still the same, and we have another limit. H goes to 0. The second term. Cosine of x sine h. Divide this by h. Alright, it's not over yet. So let's take a look here. We want to find the limit when h goes to 0. This is what matters. Same thing here, h goes to 0. But then we have this term right here, sine x. This is sine of x. It has nothing to do with h. So this sine of x doesn't really matter to the value inside the limit. So I can take this sine of x outside the limit. Okay? Because, well, it's sine of x. It has no h. Same thing here. Cosine of x, right here, has no h. So I'm going to take it outside. Doesn't matter, doesn't affect the value inside the limit. So what's going to happen next? Let's take a look here. This is equal to. Now, sine of x at the front. I'm going to change this to black, sine of x at the front, and the limit inside. Limit of h goes to 0. So what do we have left here? We still have cosine of h minus 1 left. Divide this by h. And now, okay, I need to make this tidy. Cosine of h minus 1, divide this by h. So we have to find out about this. And plus, cosine of x comes out at the front, so we have cosine of x, and we have limit of h goes to 0 of sine of h, divide this by h. Okay, now the next thing that we are supposed to do is to find out about these two values, these two limits. First one and the second one. If we can find them, then we know what is the derivative of sine of x. So the first one right here, let's leave it for later. Now let's take a look at the second one at the back. Limit of sine of h over h when h goes to 0. We have done this. I think it's last lecture or maybe a few lectures back. We know that this is going to be equal to 1. We proved this before. So this one is easy, convenient. It's going to go to 1. This equal to 1. All right. Now, this one is the problem. We have to find out about this. And we have to do some more calculations on the left-hand side. So let's work on this second limit, the first limit. Okay, this one we want to find out about this limit. Limit of cosine of h minus 1 divided by h when h goes to 0. Right now, I don't know what this value is, so I'm going to try the easiest approach, which is direct substitution. So, direct sub comes into play. Let's check it out. Direct sub, for this case, is when h to be equal to 0 exactly. So we are going to apply h equal to 0 to this term right here. So we have this term. So what is it going to be? It's going to be this cosine of 0 minus 1 divided by 0. Cosine of 0 is 1 minus 1 divided by 0, and we get 0 divided by 0. This is not good because this is indeterminate. What we have right here is indeterminate form. Indeterm, which means that there is no conclusion about this. So we have to do some more work to get a conclusion. So direct sub failed. Let's try something else. I see this fraction cosine of h minus 1 over h. I think I see a pattern here. I think I see a minus b. Over here, I think I see this a minus b. When I see this, I want to try conjugation. And let's work on this over here, down here. Cosine of h minus 1, that is a minus b, divided by h. So let's apply conjugation. Okay, conjugation. So what is it going to be? I need to apply, to multiply a plus b, which is cosine of h plus 1 divided by a plus b, cosine of h plus 1. So let's make a note up here that this over here is a minus b, and over here on the right hand side is a plus b divided by a plus b. Conjugation. So let's see what's going to happen here. This is going to be equal to, well, a minus b times a plus b. We are going to get a squared minus b squared, front square minus back square. So front square, cosine of h square minus back square, 1 square, which is equal to 1. And what about down here? We have h times cosine of h plus 1. At this point, I am going to apply another trigonometry property. I'm going to apply it to this term right here, cosine square minus 1. Does that sound familiar to you? So let's take a look here. Sine of x squared plus cosine of x squared equal to 1. I think everybody here knows this. So with this, we are going to move things around and we get cosine of x squared minus 1 equal to minus of sine x squared. So it's going to be equal to that, which means that this is going to be equal to, this is equal to minus sine of h squared. Okay, for this one, sine of h squared divided by h of cosine of h plus 1. Oh, that's long. Now, let's take a look at this term right here. We have to do something with this. This is, well, it still looks complicated. So I'm going to do something with this term. I'm going to split it into two parts, into a product of two subfunctions. So I'm going to split sine h over h out. Okay, looking at this, I am going to split sine h over h out. So this is going to be the first one, the first term. I split this out. Sine h over h. So this is the first term. And what is left over here at the back is going to be this. Alright, what is left is another sine h, and we still have that minus sign. Alright, so multiply them back together, you get minus sine h squared. Now over here at the bottom, at the denominator, we have cosine of h plus 1 left. Cosine of h plus 1. And that is the second term. You multiply these two together, you get what we have over here. And now, don't forget that we still have the limit from the beginning. So don't forget to put limit right here. Limit when h goes to 0. I want you to take a look at this. We are looking at a limit of two subfunctions multiplied together, right? Two subfunctions multiplied together, which means that we can distribute the limit to each one of them and we keep the multiplication intact. Sort of like what we did with the plus sign, but now it's going to be multiply. Multiply, dot over here and dot over here. Limit of the multiplication of two subfunctions is going to be equal to the limit of the first subfunction multiply the limit of the second subfunction. So, limit goes into each one of them. First one and second one. Now, this is going to be equal to limit h goes to 0, the first subfunction, that is sine of h over h. Looks good. First one. Now, second one. Limit of h goes to 0. Now, we have minus sine of h over cosine of h plus 1. Okay. I'm going to work further to the right hand side, so let's follow this. Now, let's take a look at the first one. First limit over here. This is limit of sine h over h when h goes to 0. It's the same as what we had on the right hand side. This we have proved that, and it's going to be equal to 1. So this right here goes to 1. As you can see, this is 1 times the other limit, so 1 doesn't really matter here. So what we need to do right now is to find out about this term. What is it equal to? At this point, I don't know. So I am going to apply the easiest approach, direct sub. So direct sub, okay, d sub, and that is when h equal to 0. Now it's going to be equal to, well, 1 at the front doesn't really matter now. I'm going to leave it out. So let's take a look at the second limit. So what do we have here? Minus sine of 0. Okay. Divided by cosine of 0 plus 1. So what do we have here? Sine of 0, that is 0. So we have, well, minus 0. Divided by cosine of 0. We know that this is equal to 1. 1 plus 1 equal to 2. Okay, minus 0 over 2. This is not indeterminate. We know this value. 0 divided by 2, we have 0. So in the end, right here, we have this equal to 0. And that is the limit of this term right here. And it's going to be equal to this limit right here on the right hand side. Same term, which means that this is going to go to 0. All right, so I think we got everything figured out. So I'm going to make a boundary right here. Okay, so that is not confusing. So what do we have here? We have, well, we still have this sine of x. Now the limit, the first one, becomes 0. We have proved it. So this one times 0 plus cosine of x still here, and the second limit, we found it to be equal to 1 times 1. So this goes to 0, and that's why we have this as the final answer for this derivative, and it's equal to, and this is equal to cosine of x, just that at the end. Okay, what about, well, this is good enough. So this is the final answer for derivative of sine of x. I know it's long, but it all comes down to this definition right here. This simple definition, the slope of the smallest triangle possible, and that proves why when we differentiate sine of x, we get cosine of x down here. And it goes for every property that we learned when it comes to differentiation. Now let's take a look at this. These two graphs right here on the left hand side. What we see right here is the graphs of sine of x and cosine of x. So the top one right here is the graph of sine of x, and the second one down here is the graph of cosine of x. I want you to take a look at this sine of x and take a look at the first, I'm going to say first wave of sine of x. So it's this one right here, first wave. Okay, let's call this the first wave of sine of x. And let's do the same for the cosine of x. The first wave, it's going to be right here. Now, with these two, I want you to compare them. And I want you to compare them at the same time or at the same angle. Okay, what about at this point at x equal to 0 degree? Right here at the beginning. At this point, what about this is enough? I want you to compare these two first waves at this origin. As you can see here at the origin, for sine x, it's still at the beginning of the first wave. So what you see right here, beginning, start of first wave, right? Right here at the tip of the wave. But when you look at this, at the cosine graph of the cosine of x, at this same point, it's already at the first peak. So for the cosine, it's already at the first peak. Okay, for sine, it's still the beginning. For cosine, it's already at the peak. So this is like, the graph of cosine is like ahead of the graph of the sine of x. And that's why sometimes you are going to see this, this property. It's going to say that graph of cosine of x is leading graph of sine of x by 90 degrees. So let's make a note right here. Cosine of x is considered to be leading sine of x by 90 degrees. Leads sine of x by 90 degrees. Or you can say that graph of sine of x lags graph of cosine of x by 90 degrees. You can say this the other way around. Sine of x lags following cosine of x by 90 degrees. So these are the properties between them in terms of, well, comparing the lagging and leading. Okay, now we have proved why derivative of sine of x equal to cosine of x, and once again it all comes down to the simple definition that we learned from the last lecture. Now let's move on to the more examples in the next slide. For these examples, we are going to have to apply the basic differentiation rules. So this will be the key. Differentiation rules. So let's start with this one right here, number 1. What do we have here? We have y equal to x to the power of 4 or x to the 4th plus 12x. So keep in mind that what we have over here on the right hand side of this equation, x to the 4th plus 12x, this is the function f of x. It just turns out that we set this function value to be equal to y in this example. So make a note up here that the function value fx turns out to be equal to y in this one. And now we want to find derivative of this function, or this y. So we want to find f prime of x, which is going to be the same as y prime, because they are both equal. You can choose to represent them as df by dx if you want, df by dx, or dy by dx. Same thing here. Now let's find this y prime. We are going to have to differentiate these two terms, x to the 4th plus 12x, and we are going to differentiate them each term one by one. So let's start with the first one, x to the power of 4. When you see something like this, x to the power of something, this is going to go to the power rule. So definitely power rule. And with this, you know, if you div this x to the power of 4, the power is going to come down. So we are going to get 4 right here. And we still have x. And the power of x decreases by 1. So right here we have 3 instead. There you go. That is power rule. Now let's move on to the next term. Oh, by the way, we still keep this plus right here. And now we can try to differentiate this. 12 times x. As you can see here, we have a constant. This is constant multiple rule. So we have constant at the front. So constant at the front doesn't really matter. So we are going to have this 12 right here at the front, and we still need to differentiate x with respect to x. When you see this, x alone, it's actually x to the power of 1. Okay? So let's apply the power rule here with the power of 1. Let's see what happens. So we have 4x cubed plus 12, and now we differentiate this x to the power of 1. So 1 is going to come down. Same rule. So 1 comes down, and then the power of x decreases by 1, so it becomes 0. And as you can see here, x to the power of 0, it's going to go to 1. And that's why this doesn't really matter here. This is also 1. So in the end, we have this 4x cubed plus 12 as the answer for this first example. Easy stuff, right? Now, let's move on to the second example over here on the right-hand side. So here we have y equal to a product of two groups, x squared plus 1 times x cubed plus 3. Once again, what we see right here is the function of x, and it's just equal to y in this case. Now, we want to find f prime of x. Once again, we want to find this f prime of x, and it's going to be equal to y prime. So we are supposed to differentiate this product. And as you can see here, we can't just differentiate this like we used to do on the first example, because we have a product right here between them. This is different. In the first problem, we have plus, so that is not that is simple. But now it's a product. Once we have a product, it's going to be product rule, right? Because we have a product of two groups of terms. First one right here, first group, and this one is the second group. What about we name them? What about I name the first group to be u of x? Right here, what about I change color? Okay, first group, green, to be u of x. A group of terms that depend on x. Now, second group right here, I'm going to call it v of x. The second group of terms that depend on x. Now, we have a product, which means that we have to apply product rule. So we need to apply product rule. And as you know, this is front diff back plus back diff front. V du plus u dv. Let's apply that over here. Front. Oh, what about I mix it up? So this is supposed to be u dv plus v du. Okay, actually it's the same thing. You can switch the order. It doesn't matter here. So front u dv plus back v diff front du. So let's use that. So equal to, now the front term, we have to take this whole term right here, x squared plus 1. So whole term we have x squared plus 1. And now we have to find dv. We are supposed to differentiate the second term. Differentiate this. In this term we have a plus sign between them, so we can just differentiate each one of them one by one. So let's start with the first one right here. Let's diff this with respect to x. This is x to the power of something, right? So power rule. So here I'm going to have, let's diff x to the power of 3, x cubed. 3 comes down, and the power of x decreases by 1, so it becomes 2. Okay, that's easy. Now, the second term, let's diff this with respect to x. This one is a constant, so this is constant rule. You diff a constant alone, it becomes 0. So this is 0. Since this is 0, I'm going to take it away. Keep it like this. Now, plus back term, which is the whole terms, x cubed plus 3. Diff front, I'm going to diff this front term with respect to x. So let's diff this one by one. Start with this one. Diff x squared. 2 comes down. Power decreases by 1, so power of 1. Now I diff this constant. It goes to 0, so nothing more after this. So just like that. Now let's multiply everything in. So what we have here is 3x to the fourth plus 3x squared plus 2x to the fourth plus 6x. So combining all these terms, simplify them. We have 5x to the fourth plus 3x x squared, plus 3x squared plus 6x. And that is the answer for this second example. 6x. Not too bad, right? So for this one, we need to apply the product rule. And let's move on to number 3. Number 3. So we have y equal to 1 over x times a group of terms x squared plus 1 over x. And once again, remind ourselves that this is function of x. And we want to find the derivative of this. F prime of x, and it's going to be equal to y prime. Now we need to diff this whole term. Looking at this, it's similar to what we had for the second example. We have a product. So let's take a look here. We have a product. First term and the back term right here, and we have a product between them. Okay, so what about we do the same? We have u of x over here, and for these terms, it's going to be v of x. And we see something like this, a product. Of course, product rule. Product rule. So let's do that. It's going to be front diff back plus back diff front. Front diff back plus back diff front. Okay, let's do that. Front term, nothing changes here, 1 over x. Diff back, so I'm going to diff the second group here, 1 by 1. Diff this one is easy. 2 comes down, and power decreases by 1. It becomes x to the power of 1. Now, I'm supposed to, plus this, and I'm supposed to diff this. Diff 1 over x. What is it equal to? Okay, we want to differentiate 1 over x with respect to x. At this point, some of you may be scratching your head and you don't know what to do because we don't have this in the formulas in the sheet that we talk about the basic rules, right? We don't have this. What about we look at this 1 over x in a different way? What about we look at it as x to the power of minus 1 equal to 1 over x? Let's look at that as x to the power of minus 1. Same thing, right? 1 over x, x to the power of minus 1. And now we want to differentiate this with respect to x. Now, 1 over x becomes x to the power of something. So we can apply the power rule here. So it's going to be equal to power rule. Power comes down. Minus 1 comes down, becomes minus 1 at the front. And the power decreases by 1, so it becomes minus 2. So here we have, in the end, it's going to be minus 1 over x squared. Alright, so keep in mind, you diff 1 over x, you get minus 1 over x squared. So that's what I have over here. I diff it, and I get minus 1 over x squared. Okay, so we have 1 over x squared, and I'm going to have to change the sign to minus. Alright, now for the back diff front, plus back is everything here, x squared plus 1 over x times diff front. I'm going to have to diff this, the front term, 1 over x. By now we know it's equal to minus 1 over x squared, so let's use that. Minus 1 over x squared. Okay, when you get a result like this, don't leave it like this. Try to simplify it as much as you can, because this doesn't look nice when I grade it. So let's try to multiply these terms in. So this becomes 2. This becomes minus 1 over x cubed. Now plus. Okay, what about I take this plus away? So this goes to here. It becomes minus 1. So I have minus 1 right here, and this terms goes here. It becomes minus 1 over x cubed. So this is minus 1 over x cubed. So combining all these terms, 2 minus 1, I get 1. I get 1 right here. And minus 2 over x cubed. And that is the answer for this example here. What about I make a box around the answer, the final answer? Right here, and for this one as well. And for this one. And I don't want this. Let's take it out. Okay, now we got the answer for number 3, but I just want to tell you that there is another way to do this problem number 3, and it's going to be easier. So let's take a look here. So instead of applying the product rule, I look at this function. I take a moment with it, and I think I can do something with it before I start to differentiate it. What about I multiply 1 over x inside first? Okay, so a different version to do this problem. So y, okay, what about this? Option 2, optional. So I'm going to work on the multiplication first. Y is going to be equal to 1 over x is going to go inside at first. So this, what about I write it again? I think it gets messy. Okay, we have 1 over x times x squared. Okay, x squared have x squared plus 1 over x. I'm going to multiply this in the parentheses first to these two terms. It might make my life better. So let's try that. So 1 over x times x squared, it becomes x. 1 over x times 1 over x becomes 1 over x squared. So this is also equal to function of x, same thing. And now it looks much simpler. And at this point I can try to find the f prime of x. Now y prime equal to f prime of x, and I need to differentiate these two terms. And with these two terms I can just apply the power rule, right? So let's do that. Differentiate this with respect to x, it becomes 1. Okay, diff x, you get 1. And now you diff this 1 over this term right here, 1 over x squared. Let's do that. What about I try to differentiate this? When I look at x, 1 over x squared as x to the power of minus 2. 1 over x squared is equal to x to the power of minus 2, right? So I can do it this way. I'm going to diff this with respect to x. And as you know, this is going to be the same rule again. Okay, 1 stays the same, and diff this. Power is going to come down, minus 2 comes down, and power decreases by 1, x to the power of minus 3. And this is equal to 1 minus 2 over x cubed. Same, right? Same as what we got earlier. But this time it's much simpler. We don't need to apply the product rule. We just need to simplify it before we start the differentiation. Okay, so this is what I'm telling you. This is important. Sometimes you see a problem and it looks complicated or difficult. Take a moment with it. Take your time. Look at it. Sometimes there is a way to simplify it first. So this is the key. Try to simplify your function first. Important here. Try to simplify before starting. It can make your life much easier before starting to differentiate. Okay, do not rush in the beginning. Now let's move on to number 4 right here. Once again, this is equal to what we got. Now number 4, let's make a line a boundary. So we have, for this one, we have y equal to a fraction, t squared minus 1 divided by t squared plus 1. So we have a fraction, and once again this is equal to function of x. And looking at this, I take my time, I took a moment, and from the look of this, I don't think I can simplify it. The best I can do is to do something with this t squared minus 1. It's going to be equal to t front minus back times front plus back divided by t squared plus 1. But this doesn't go anywhere. I cannot get any cancellation here, so I don't think this is going to work. Now I see it this way. I'm going to apply the quotient rule. I have a fraction. Quotient rule is the key. So looking at this, I know it's going to be quotient rule. Alright, quotient rule. Let's name the numerator u of x, the first group, and down here v of x. And we want to find this y prime equal to f prime of x. Quotient rule, down diff up minus up diff down divided by down square. So down v diff up du minus up u diff down dv divided by down square v square. So we have to find all these terms. There is no way around this. So equal to, now v, the denominator, we have t squared plus 1. Now du, we are supposed to diff the numerator here 1 by 1. So diff t squared, we get 2t. 2t. And we diff minus 1, we get 0. Diff a constant, you get a 0. Minus u, numerator, 2 squared minus 1, diff v. Diff these 1 by 1. Diff t squared, you get 2t. Diff plus 1, you get 0. So that's what you have for the new numerator. So now you need to divide this by v squared, and that is t squared plus 1 square. Okay, now we have to work on these terms. Do not leave it like this. So this is going to go in, 2t goes in, becomes 2t cubed plus 2t. Now minus 2t goes in, becomes 2t cubed plus 2t. And divide this by the same term, t squared plus 1 square. And we get some cancellation here. 2t cubed minus with 2t cubed. So what we have right here is equal to 4t for numerator divided by t squared plus 1 square. And that is the answer for this example number 4. 4t divided by t squared plus 1 square. Not too bad, right? So let's move on to the next slide, and we have example number 5 and number 6. It's going to be a little bit more challenging. So let's take a look here. Example number 5. So this is the function that we have. This is equal to f of x. And we have both a product and a fraction and a division. So we have this x minus 1 times this group of x squared minus 2x divided by x to the fourth, and it's going to be, well, it's going to be a little bit harder. So make a note right here that we have both product and division. So looking at this, of course we have to apply the product rule, right, and the quotient rule. But first of all, what about quotient rule? Because we have this outside. Okay, this is the main operation. We have one group at the upper part and another group at the lower part. So we are going to apply this, name this, the top of the fraction to be u of x, and down here is going to be v of x. At this point, it becomes clear that we have a fraction between u and v, and we can apply the quotient rule. So with this quotient, and it's going to be v du minus u dv divided by v squared. So let's work on that. Y prime equal to v du minus u dv divided by v squared. How is it going to turn out? Let's find out. So equal to v, first term, v, that one is easy, that is x to the fourth. So we have x to the fourth right here. And now we have to find out about this du. This second term, du, it means that we are supposed to diff this. Everything here. Diff these product, the product of these two terms. And we have to find out, we have to put it right here. So what about I do this step by step? We are supposed to do this. We are supposed to diff the numerator, the whole thing. Okay. X minus 1, x squared minus 2x. And we are supposed to diff this with respect to x, and that is going to be du. Minus u, this one is easy, u, x minus 1, I don't think I have enough space. Okay, x minus 1, what about I save some space and write it again? Sorry about that. Didn't expect this to be this long. Okay, equal to. Okay, equal to v. This one is x to the power of 4. Now du, we are supposed to diff the numerator. So diff numerator, we have x minus 1, x squared minus 2x. Diff this with respect to x, and that is du. Now minus v, minus u. U is this whole thing again. X minus 1, x squared minus 2x. And now dv. That was u, and now we have to find dv. So we are supposed to diff this x to the fourth with respect to x. What is it equal to? It's going to be 4x cubed. Power comes down and power decreases by 1. So over here, let me use a different color. 4x cubed, 4 dv. And for this one, what about I use different color too? X to the power of 4. Now we have to divide this, everything here, with v squared. And that's going to be x to the power of 8. It's not over yet because we are supposed to differentiate this term, this product, a product between two groups of terms that depend on x. So we have right here a product. So we have to apply the product rule. Product rule. Okay, let's try to write it. Equal to. Now x to the fourth stays the same. And now we apply the product rule. Front diff back plus back diff front. So front, okay, let me make it clear to you. This is front and this is back. Once again, this is u, x, and this is vx. So this front is x minus 1, and we are supposed to diff the back, this one right here. Let's diff it. So this is going to become 2x for the first term. 2 comes down and the power decreases by 1. And now I diff minus 2x, I get minus 2. Okay, right here, minus 2. That is front diff back. Now plus back v diff front. Now I need to diff this. X minus 1. Diff x, I get 1. Diff minus 1, I get 0. So that is the product rule. So what you see right here, this is u dv plus v du. Alright, now that is the front term. It's not over. Okay, back term right here is still the same. Minus x minus 1 and x squared minus 2x and times 4x cubed. 4x cubed. And we have x to the fourth right here. And we are supposed to find out about this and then divide this with x to the power of 8. Okay, if we continue doing this, it's gonna be a nightmare. This is really complicated, and we run into this situation because one mistake, and that mistake is that we didn't take time to look at the problem that we have. We didn't take a moment. We didn't check whether it's possible to simplify it before we start differentiating. So we are going to start this problem over again. So let's take a look at this function again. Well, we can make a note right here that this is too complicated. This one, too complicated. And our mistake was we didn't try to simplify. Didn't try to simplify first. So we are going to start over. Let's try to simplify this function right here. A product and a fraction. What about I don't like a product? What about I multiply these two products together and combine them? Let's do that first. So y equal to, let's multiply these two products. Multiply this product between these two terms. So x goes to here, x times x squared. I get x cubed. And once again, x goes to this one. X times minus 2x, I get minus 2x squared. And next one, minus 1 goes to x squared, I get minus x squared. Minus x squared. And last one, minus goes to minus 2x, I get plus 2x. Plus 2x. And now I can combine some terms here. Oh, don't forget the x to the fourth. X to the fourth. And I can combine these two together. So let's write this right here. X cubed minus 3x squared plus 2x, and divide this by x to the power of 4. And now we are supposed to, well, it looks better. It looks simpler. What about, make a note right here, simplify. Very important. Well, right now we have a fraction. And it looks better, but I don't like fraction. Fraction means that I need to apply the quotient rule. And I need to apply that down diff up minus up diff down divided by down square again. That's a lot of calculation. What about I apply this x to the fourth to each of the terms in the numerator directly? Let's see what happens here. So instead of looking at this function as a fraction, what about I look at this as this. Multiply this with x to the power of minus 4. And I'm gonna get rid of this. X to the fourth down here. It's gonna be the same meaning, right? Times 1 over x to the fourth. Now with this form, I can distribute x to the power of minus 4 inside. So first term goes with minus 4. It's going to become x to the power of minus 1. Okay, next term. This one times x to the power of minus 4. I get minus 3x to the power of minus 2. Next term, plus 2x to the power of minus 3. At this point, I think I'm going to apply the differentiation now. I think it looks good enough. So at this point, I diff this. Let's diff this, these terms, differentiated. Which means that for all of these terms, we can only apply the power rule. First one power, second one power rule, and last one power rule. So let's take a look here. Y prime is going to be equal to, let's diff the first term, power rule. Power comes down, minus 1, and power decreases by 1, becomes minus 2. Next term, we have power of minus 2. Minus 2 is going to come down, times with minus 3, it becomes plus 6. Plus 6, and the power decreases by 1, minus 3. Next one, we have this constant times x to the power of minus 3. Diff this, minus 3 comes down, it becomes minus 6. Minus 6, x to the power of, well, minus 3 decreases by 1, we have minus 4. And there you go, we have y prime. And I can write it as this, equal to minus 1 over x squared. Alright, plus 6 over x cubed minus 6 over x to the 4th. And that is the answer for this example number 5. That's all. That's all it takes to solve this. And you could manage this because you simplify it first. Okay, so you can compare between these two approaches. Looking at this one on the right hand side, we start without checking anything. We didn't take time, and we run into this nightmare, and we couldn't keep going. But on the other hand, if you, well, try to simplify your function first, and your problem becomes much easier, and your life is much better too. So try to simplify first. I can't emphasize on this hard enough. Okay, try to simplify. Now, let's move on to the last example of today. So let's take a look at this one right here, number 6. What do we have to do here? We are supposed to find the equation. Okay, so, alright. Now, we want to find the equation right here. So right now, it's not just y prime. We want to find an equation of something. Of what? For the tangent line. So it's going to be equation for tangent. And as you know, tangent is straight line, linear line. So you want to find an equation of a linear line. So you know right away that for this one, you are supposed to find this. Find y equal to ax plus b. But at this point, you don't know what a and b are. So we have to find out about this a and b, because it's for the tangent line to the what? To the curve. So we have a curve at the end. So this is the function that we have to study. For this one, once again, this is f of x. It turns out that f of x equal to y here. And we want to find the equation of the tangent for this curve. And there is one information that is missing from this example. You have to specify a location, a point, to study this tangent. So this one is missing, so let's put it in. What about at x equal to 2? So let's add it in. At x equal to 2. Alright. Without the location, we can't continue. So now we have all the informations that we need. So how do we find this equation? First of all, let's talk about the concept. How do we associate derivative to tangent? Okay, think about it. At this point, we should know that when it comes to this f prime of x, derivative of f, it's going to be associated with the slope of the tangent, right? Slope of tangent to the function curve, to fx, or y in this case. So, which means that this f prime of x is going to be the slope of the tangent. And the slope of the tangent, let's look at this again. This is the equation for the tangent. The slope of this straight line is going to be this a right here. This one is the slope of tangent, which means that we know that f prime of x, if we can find it, it's going to be equal to the a that we wanted. Okay, So this is the key. Now we need to find derivative so that we know what a is. Now back to this, y equal to x plus 2 over x. That is our function. And now we want to find derivative. Let's do that. Y prime equal to. Now we are going to diff this. And at this point, this one should be easy. We are going to apply the power rule. So diff the first term, it's going to be 1. And second term, what about I use this? 2 over x equal to 2x to the power of minus 1. Right, same thing. Make a note right here. So we want to diff that. So if we diff this, let's diff this. Minus 1 comes down, becomes minus 2, and power decreases by 1, minus 2. So what we have over here is going to be equal to minus 2 over x squared. There you go, we have this derivative, and this one is for any values of x. But we want to know this derivative when x equal to 2. So we have to use this, x equal to 2. What happens to this derivative? So this at x equal to 2. Let's continue. At x equal to 2. So y prime at x equal to 2 is going to be equal to 1 minus 2 over 2 squared. So we have this 1 minus 1 over 2, so we have 1 over 2 here. There you go. So that is derivative at x equal to 2. This is deriv at x equal to 2. Okay, x equal to 2, and at this point we know this is equal to a that we want. Slope of the tangent. Slope of tangent at x equal to 2. Now we know what a is. A is 1 over 2, but we don't know what b is. So we have to continue. Let's work some more. We have to find b. Okay, next goal is to find b. Find b. How do we do that? So we can use the equation itself to solve for that. So we start with this equation, y equal to ax plus b. Let's use that to find b. At this point, we know what x is. We know what this is. This is 2, x equal to 2, right here. We also know that a is equal to 1 over 2, right here, 1 over 2. So we know what this is. At this point, we still don't know what y is, and we don't know what b is. And what about we find out about y? At this point, x equal to 2. Can we find y? Can we? Of course, we have the equation right here. If you know x, of course you can find y. So let's do that, well, down here. What about right here? Y at x equal to 2 equal to 2 plus 2 over 2, right? Using this right away, the equation that they give to us. So this is equal to 2 plus 1, so we know y equal to 3. So this one, good now. We know it's equal to 3. Let's put everything in. So y equal to 3 equal to a equal to 1 over 2, x equal to 2. Now, plus b, that is what we want to know. So with this, we can find b to be equal to, well, 3 minus 1. So we have b equal to 2. Well, this is not the answer. Do not stop here. They ask us to find the equation. Back to the question. They ask us to find this. So we are supposed to give this to them. Alright, so we are supposed to give this. Answer right here. This is the equation. Y plus equal to a, which is 1 over 2, x plus b, we found it to be 2. And there you go. This is the equation of the tangent to this curve at x equal to 2. Don't forget that we are supposed to find that. And that is the last example of today.